guys in the race because they were in first place halfway through. You don't get credit for a paper you're writing if you say, well, gee, I had it done, I was at halftime, I had the paper pretty much done, but I didn't get it done on time. You know, most people don't care, they want it done on time. So there's a report or whatever it is in the real world out there. You do not leave someone else who's dependent upon you stranded in the world if you want to keep your job. And that's true with just friendships, it's true with everything. You don't sacrifice in stupid ways. Friendships, what your responsibilities are in life, and so on. It's simple. Anyway, this exam, at this point I haven't finished writing it. I've got, the plan is 20 multiple choice questions with 5 options to choose between. Some being whatever, the options. Some have A and D are correct as an option. Okay, something like that. So, sometimes there's nothing correct. So you have to sit there and think about it. And I like to think I write multiple choice questions that actually make you think. It's not just a matter of math. Well, that's obviously, these are all obviously wrong. They're stupid, things kind of stuff. So they're supposed to be thinking questions. There'll be a couple of short answer essay questions, something like you see on the homework assignments. That third homework assignment I gave you, I started writing the answers to it and I realized this is way out of line. So in terms of the detail I was looking for, and so that's why I canceled that assignment. Yes?
So are you gonna have anything that was covered on homework 3 on the test, or just?
No, it could be, but it's not gonna be those questions. Those questions were a lot of complexity to them if you so I just decided, you know, what am I doing here? I didn't think about it when I wrote the questions out until I started writing the answers. So I'm going to go over here in the beginning the aggregate production framework. This is an aggregate production function. There's a version of that function which is famous in economics now, called the Cobb-Douglas production function. Cobb was a mathematician, Douglas was an economist. Cobb was at Amherst and Douglas was at the University of Chicago, also a famous senator. They came up with a very simple mathematical structure that explains a lot of how production activities actually work from the empirical side. So it was a very useful thing. It's also used if you go on in economics or finance and you get to preference orderings, how people make choices given their preferences. There's a Cobb-Douglas, it's called a Cobb-Douglas function. And it's a utility function or a preference function. And so there are a lot of cases where you take these very simple functions because they discipline your thinking. It's good to have a little bit of discipline in your thinking. Sometimes, you know, it's economists are criticized for this. Oh, you got all these, you don't have enough variables here. You know, you're ignoring all this stuff. And the point is we like to cut through it and say, well, what's really important here? Okay, not what is possible. And that's certainly the case in macroeconomics. It doesn't have a high respectability for among economists, especially people who consider themselves theorists. I have a really good friend who's, when I was at UCLA, who's a theorist, and he was telling me about macroeconomics once we were talking. He didn't know what the heck he was talking about. He was just, he didn't understand what it was because he was, quote, a theorist but didn't think in that arena. And so anyway, it's, he didn't understand monetary policy. So we put ourselves sometimes in very narrow cubby holes, if you will, based on our research. And there are people who study labor economics who don't know anything about other aspects of economics, really, other than certainly the methodology they're exposed to. But the profession has become more and more narrowly trained in terms of what areas an economist would be knowledgeable about. And there's a lot of times in which people are, I used to argue with people who were, most of them were non-economists. A lot of them were lawyers who had very high opinion of themselves on what they know about everything. And I used to argue, now I just listen and quietly amuse myself. There's a lot of crap out there floating around, and you need to start developing some discipline on, if you don't start out with it, to develop it, to understand what's, yeah, just what it is. So hopefully you'll get some of that out of this class. And I'm going to talk a little bit about this aggregate production part of the model, which is the supply and demand of the aggregate output, known as GDP, gross domestic product. And we went through the nominal GDP and real GDP. A number for GDP in and of itself is worthless. It's a number you use to compare to other issues. You use it to transform. GDP per capita, that's meaningful. Now I can see how many participants are there in this economy, and what's the sort of average share if they all got an average share, and where do I lie on that? Am I above or below average? Okay, so that's meaningful to some people to know where they sit in the spectrum out there. I've seen that go over the hill when I was at Tulane University teaching. There were two colleagues who were arguing over, first of all, how many papers have you published in the last whatever number of years? And then it got to, well, how many equations did you have in the papers? How much math did you have? And on like that. They kept competing with each other with this ridiculous comparison. They didn't talk about the quality of the papers, they were just talking about the math, whether this or that. And sort of their little rivalry with each other. And so that's that. Okay, so I want to turn here. Oh, I have something for you I want to mention before I do this. As I have an article here, you don't have to read it right now. Okay, but it has to do with technology. Okay, this is something that is phenomenal. Back in the late 1970s, I went to visited a General Motors assembly line, automobile assembly line in the city of Industry here in LA. And I watched cars coming out of the assembly line. And they were doing Buicks and Chevys and one after another, but all the parts would come in for the right car. The time they have this kind of conveyor system to bring the parts into the particular points on the assembly line where they're being assembled. And it was kind of impressive. You had all these workers down there putting the cars together and so on. So it was interesting. We walked down the assembly line. I walked down with an inspector who explained to me how the process worked, and they said we have an A team, a B team, and a C team. You want your car built by an A team group, not a C team. When they assemble cars for dealers, they actually have one of these quality control people walking the car right down the assembly line to make sure they're doing it right, and that there's no defects or anything, and because they don't want to have a dealer having their car break down. Not good for the advertisement. Anyway, so I saw this. It was interesting. And then I saw a picture, which I'll give you here, about an assembly line today. There are no people. It's all assembly line robots that are programmable computers. Now, there are people employed doing that, but there's no workers there anymore. Today, and what it points out is what's happened in the labor market, especially here in the manufacturing sector of the economy. There were, I think, what was it, 18 million manufacturing workers out there. Today, there's only 12 million in a period of about 25 years. Robots have taken over. You can look at these ships going by out here transporting things now. They used to have cargo ships that you actually carried cargo onto the ships and so on like that. It was either forklift stuff. Now it's all in what are called intermodal containers. You take from one mode of transportation, dramatically lowered the cost of transporting goods. Some of them are refrigerated and so on like that, and so they can move food items and so on around. And so when you look at these large ships going by out there, almost all of them except for oil tankers are ships that are cargo ships that are carrying container ships, huge ships too. They carry thousands of these containers, okay? And so it's anyway, so that's just another area. You do not have dock workers anymore. You have truck drivers. You have people operating it because the intermodal can be moved from one form of transportation to another. It's just a box, okay? And so it's an interesting world that we have out there now, relative to the world when I came into to here. Compared to when I went to that assembly line, I mean, I saw all these people out there putting lug nuts on and doing all this stuff. It's all done with machines now. Okay, and you can see that in the picture here. I don't have a picture. One time in the past, I had two pictures. I had another picture, not this one. But anyway, this is an article that's just making introducing a suggestion of what's been happening in this world with that blue-collar labor force out there, and how they've been, to some degree, destroyed with robots. Okay, that's not what you hear from our president these days. It has to do with foreign competition and low wages elsewhere and all this kind of stuff. And actually, industrial production in this country has gone up. Labor has not. So you have a huge number of people who are not living the life. Industrial workers, I had friends who grew up in that world, and they lived out in the San Joaquin Valley. They had a home, 3 bedrooms. They had 2 cars. They had a pickup with a trailer. They had a boat, maybe a dune buggy, and on and on. There's real, those workers can't afford that anymore. Okay, wages have not gone up, and a lot of them have lost their jobs, and they've got high school educations. You know, what are you going to do? Are you going to go back to try and get a college degree at age 45 or something? That's getting pretty late. Okay, so I just, you know, guess the upshot of this, I have a point to make, you want to take your education seriously. The world is not good to you out there. I'm not saying you can't if you're incredibly talented at certain things, okay? You could be a Picasso or something like that and be a great painter with virtually no education. But you really, if you're a middle of the road out there now, it's not a good way to continue in this world that way. And that's why a good education, it could be a good technical education, it could be whatever, but the world is moving to robots. My job's in jeopardy too, because you can just have one teacher broadcast an economics course and it can go out throughout the world. Okay, so what do you need bachelor for? To substitute for somebody else. So we're all potentially in that. I'm just going to hand these out in lumps. Let them flow. In fact, I'll just start it right here. Thank you. Okay. So on this chapter now, the chapters we have are these chapters on GDP and so on like that, and I got the notes I gave you on the different definitions, what unemployment and so on that I put out there, some of them I've written up, and it's I started this course with a very simple little framework. Robinson Crusoe on an island. And what I wanted you to see a couple of things was, first of all, what was the economic problem for Robinson Crusoe? Well, he lived in a world where there was scarcity. He made decisions. He made production and consumption decisions simultaneously, because when he made a production decision, it could become a consumption outcome. And so, but I started him out with opportunities. In that case, a production possibility, set of production possibilities between two good, X and Y. And I had a frontier, frontier which was what was technologically possible given his resources in terms of these two goods. And so it was a boundary curve thing. And then I took information from that, and I said, well, where's he going to go? And so I took information from that to determine the marginal cost, the incremental cost, not the total cost, the incremental cost. How much does it cost to produce each additional unit? And the cost of producing an additional unit of X is how much Y do you have to sacrifice? How much time or effort is sacrificed? How much of another good could he have produced in that same period of time when you produce a unit of goods that you're specifying here, say units of X. How much Y did you sacrifice at the margin? And so we saw that when you constructed the marginal cost curve, which is what it is, how much the cost is how much of the other good you have to sacrifice. Then the question is, you need to define his preferences, and I gave a marginal valuation schedule, what it was worth to him, what he would be willing to sacrifice at most to get each additional unit. And we saw where the marginal valuation schedule intersected the marginal cost schedule was where he maximized his welfare. Economics, almost all the problems we have in economics are broken down into marginal analysis. The beauty of marginal analysis from a mathematical point of view is it's calculus. What's the marginal cost or something? This is the first derivative of the cost function with respect to the. And the same is what I see here, and I'll refer to that when I go through this production discussion in the aggregate here. Is that it's really all calculus. And that's why in economics we require you to take a calculus course at least, and also in business you have to take a calculus course because it's the same methodology. Okay. So, and it makes sense, and we use mathematics. Okay. not complex mathematics, by the way. Very simple mathematics, because it puts structure and discipline in your thinking, okay? And so, a lot of the world out there just talks. You know, blah, 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 blah. And they're not even, they obviously never at a certain level make any assumptions clear, where they're coming from and what they're doing. You have to kind of then figure out what's going on. And so that's the world out there. There's a lot of talk, and no substance. And I also believe that people can believe whatever they want to believe. And you certainly see that out there in the world in a lot of different ways. You see it with different religions, you see it with different this, and people believe things as if they're absolute truth, which is fine. That's maybe it makes you feel comfortable. Have a solid grip on something. Anyway, what I want to do is start with a simple function here. Function is a rule that assigns a single number to a set of numbers. Okay? So I take a function, and we've done this before quickly. We have output, which is denoted Y in macroeconomics. Those are real dollars. Okay? Remember, when you aggregate, you can't aggregate apples and oranges and make any sense out of it if you're just adding them up. Okay. So what you need to do, the way we do it, is there's market prices out there in a market economy, and we're talking about a market economy, we're talking about macroeconomics here. A series of markets that we're going to consolidate down to a very simple framework. So we can say something, and put a little bit of thinking, very imprecise, but that's how we begin. Okay. I remember once, when I was a grad student, there was a famous economist, one of the second person to win a Nobel Prize in economics. It was Kenneth Arrow, who was at Harvard, and he presented a paper at UCLA. It was all math. And I'm sitting there looking at these equations and everything, and I read the paper probably 3 times trying to figure out what the heck the paper was about. And this is when I'm just an early on graduate student, my second year. Okay. And I've been exposed to some of this stuff at this time. You just look at a bunch of math, you know, so what the heck is this about? And so he gets up at the presentation, and he says, okay, here's what I'm talking about. He draws a little 2-dimensional diagram. And all of a sudden, I thought, oh my God, why didn't he put that in at least a footnote or get something? Because once I saw that, I saw what the paper was about and why he was doing what he was doing. He put this very complex, mathematically complex framework up there. And, you know, you look at it, especially as an undergraduate, and I was barely out of my undergraduate life, and you think, why don't you make my life simple? Well, these are essentially mathematicians talking to mathematicians, you know, or people who are knowledgeable of the math talking to other people who are knowledgeable of math, and they understand what they're talking about. But you do this little 2-dimensional diagram on the board, and that just all of a sudden it lit up for me what he was saying. That's all I needed to see. So sometimes you can start out with something very simple and then make it more complex and elaborate and make your point in that way. But that's what he was doing. Okay, I want to be sort of a breadth of understanding of the framework here. So we have Y, that's output. What is output in our model? It's real gross domestic product, real dollars. Where did we come up with that idea? We aggregated the dollar value of all final output within a given period of time, within a given geographical boundaries of the country, the economy. We got a bunch of numbers. Those numbers were all in dollars. And then We added all those dollars up and that gave us nominal GDP. It's just a number. You say, well, what will I do with that number? Well, I don't know. It's just a number. A lot of ways to come up with a number. Okay. But anyway, it was an aggregate number, but you want to use that number to compare to something. For example, what was GDP last year and what is it this year? Okay, is the economy growing? Is it inflation that's driving it, the growth in GDP, the number, or is it real output? Well, that's where you separate out in a somewhat artificial way using a price index, a GDP price index to get a deflator, so that you adjust for changes in GDP that are due to price changes over time versus output changes. You know what real output is. Not a nice way to add apples and oranges, let me tell you, and make any sense. I can do it, but what's it mean? Okay, so we aggregate across all goods. You obviously do not add an automobile to an apple and make any sense of that. It's useful. And so what you do is you take the dollar value of everything and market prices, and you aggregate it all, and you get a number in dollars. And that's nominal GDP. From period to period, nominal GDP can change for two reasons. One, because prices of goods changed, and the other is because the quantities of goods changed, ignoring changes in quality, because that can happen too. Okay, and so you've got a number now that's a little more, you can make sense out of over time, and that's how we define a recession. An economic contraction is when real GDP declines for two successive quarters. Okay, okay, so if you have two 3-month periods of time. The recession we had, quote, in the COVID panic, it was a 2000 to 2000 roughly, okay, the year was 2000, I'm sorry, 2020, what am I thinking, didn't even meet that standard. We still called it a recession. Unemployment just blew up, huge. People were just basically temporarily laid off, go home and stay healthy, kind of approach. That was a very unusual period of contraction. It did not fit what we considered the official definition. Certainly output contracted. And you can see that in the diagram there because it has that period there with the that contraction, okay, as well as the Great Recession in the handout I gave you with that. Anyway, you aggregate the data and you compare GDP from period to period, but you compare real GDP because you want to know what really happened to output, physical output itself, services, goods, services, and so on like that. Okay, it's fairly complex. Okay, and by the way, roughly 50% of our employment in the economy now is the service sector. What are services? Well, you take your car to the mechanic. That's the service sector. When the car comes off the assembly line, that's the manufacturing sector. Okay, the service sector is maintaining the capital stock. The sum of total of all the cars out there are part of the capital stock. All the buildings are part of the capital stock. All the factories are part of the capital stock. Huge capital stock out there, and roughly 50% of the total population out there, from medical services to legal services to maintenance services of all kinds, is the service sector. Okay, it used to be that the manufacturing sector in early stages of industrialization, the manufacturing sector was huge. Now the service sector is huge. And it doesn't matter to some extent for the service sector where it's manufactured in the world, it's where it's being serviced, okay? And I think I used to jokingly say when you have when you own a Ferrari, you've got a Ferrari maintenance problem, you bring in Tony from Milan to repair it and fix it. Services come in too. Big outflow of services in this economy, just so you'll know. I taught at UCLA. I knew people who worked at I don't know. At the UCLA Medical Center, huge number of people from South America come and get medical services at UCLA. I think it costs them $1 million a piece just to get in the door for medical. It's a great medical center. There are several of these in the country. You don't go to an African country to get the best medical services you can get. Not that they're bad, but I mean, just saying that in general, you think you have a little bit more quality in these advanced countries. Some people go to Sweden or wherever. I know that it's true in Europe. Anyway, at least I was in Finland, and I know in Finland they won't do fancy medical services even though they have free medical care. And so what people have to do in Finland is they have to pay to go to Sweden to get their medical, their surgeries, certain kinds done, because their socialized medical system in Finland doesn't pay for it. Anyway, so we've got this world out there, so let me get back to this now. We have dollars of output, okay? And output includes this vast array of goods and services. And we take the total dollar value, we aggregate to get the total dollar value, and then if we're going to make a comparison with that, that's called nominal GDP. And then if we're going to make a comparison to other periods, okay, we construct the real GDPs. And the standard way of doing it for a long time is that we have a base period. And that's where we have a price index for that period. We usually, whatever the prices are, we multiply it by numbers to get it to 100. So that's the base period, just artificially determined 100. And then over time, we measure the same way. And so if prices are going up, of course the numbers are going up over 100, obviously. And we use those numbers to deflate down, because we can take a price index, if we have, which is a GDP deflator, and we have a nominal GDP, a number we have calculated, and the price index times Q, the quantity index that we don't know, but that's the only thing missing. We've got the nominal GDP number we've measured. We've got the price index for that period. And then what's left over? Well, GDP is Y. Nominal GDP is Y equals P times Q. Once we know P, once we know Y, we can solve for Q, which is real GDP. What's really happening to quantity. So we're concerned what's happening to quantity over that period. And so the real GDP just deflates nominal GDP, assuming there's inflation. It would inflate it if there is deflation, okay? But you're adjusting for prices there. We don't want to say, well, because prices went up, therefore there's more GDP, there's more output. The nominal value's gone up in money value, but the actual total output has not physically gone up in terms of goods and services. Okay, so that's what we're trying to do, okay, is to come up with that number. That's our real output number. Okay, so we have Y now, real GDP is a function of F of, a function is a rule that assigns a single number to a set of numbers. The argument's in the function itself. So f is the function, it represents a rule, and now we just put an f there, okay? And it's a function of labor and capital. What's labor? Well, we have a measurement of a labor supply, okay? It's really, in actuality, it should be, even though we talk about it as the quantity of labor, it's labor services. Okay? And the same is true with capital. It's capital services. The services of capital, the services of labor. That's what we use for meaning here. It's a positive function of labor and capital, we assume. What does it mean to be a positive function? Well, I hold K fixed and increase L, okay, output goes up, Y goes up. If I hold labor fixed and increase K, output also goes up. That's how the function assigns numbers to that. It's higher numbers. Obviously, if both inputs go up, goes up. If both inputs go down, the Y goes down. So that's just say it's a positive function. For those of you who have a little calculus under your belt, just means the partial derivative of this function with respect to L is positive, and the partial derivative of this function with respect to K is positive. That's just the simple way. As you move on in life here, in economics and business, you're going to use more calculus. So that's why it's good to have a little bit of that in your belt. So that's the nature of the interrelationship between the inputs in the production activity in this case and the output, the final output. We can measure Y, we can measure L, and we can measure K. You have to have measures of those. So there's a capital index, there's a labor index, and a labor services index, and a capital service index. So we put those numbers in the function. The function's a rule. That's probably the most famous function, the most widely used function in production theory is the Cobb-Douglas production function. Based on the work done by, I think it was Andrew Cobb and Douglas. Cobb was a mathematician at Amherst. Douglas was an economist at Chicago, University of Chicago. And they worked together for a long time to try and come up with a actual mathematical, specified mathematical formulation that captured what was going on in these production activities. And they do it both at the firm level and then at the aggregate level as well. And the Cobb-Douglas production function looks like this. Y equals A, which is a parameter in the sense, but it's a variable. That's how you introduce changes here now. One way we can introduce change. So let me explain how to do this just intuitively. We have A, we have L. A times L, and we have a power here. This is, I'm going to call it alpha. It's just it's an exponent. This is the function. It's a multiplicative function. It's going to be L to the alpha power times K to the beta power. Those are just the exponents. Okay. It's a multiplicative function. Just multiply A times L to the alpha times K. If I measure those inputs, I have a measure of A. If capital or labor change, that enters L or K. Okay? Those are changes. So over time, if the population is growing and the labor force is growing, we've got an increase in L going on. And it's going to generate more output. And the same is true if we have an expanding capital stock. Capital services are gonna be expanding, and you'll get more output. Basically, the difference between most advanced industrialized countries is that K is pretty large, and is a very large component of in this function. If you have a really poor country, there's very little capital. Okay, production capacity in the form of factories and machines and so on like that, and usually a lot of labor, but they're pretty poor. Okay, and but anyway, in the more advanced countries, you have a lot of capital. Okay, you have people working in, let's say, earth moving thing with in a poor country with picks and shovels. Once I was in Mexico City for a conference, and I was in a hotel, I was looking down there putting cobblestones in the street. Guys are down there with hammers and so on, picking these rocks up and pounding them down into place and so on like that. And I think, whoa, what happens in the US, for example? Well, the truck drives up, they look around and they say, well, Joe, have you got the coffee ready yet? You sit around and have a cup of coffee. These other guys are pounding all in the street, okay? And they go to work, they pull out their equipment, tractors and whatever it is, digging equipment and on. And they do twice the job in a very short period of time, have another cup of coffee and go home, okay? So that's really the difference between a country that's very well developed with lots of capital and so on, the labor is generally not doing that back-breaking labor that you see happen in poorer countries. Anyway, this could be to the 0.5 power, this could be to the 0.3 power. They're usually, those exponents add up to something 1 or less, okay, and those features of this production point. Anyway, this is a Cobb-Douglas version of that general function I put up there, okay? Has positive, you add more labor, output goes up, you add more capital, output goes up, okay? A is a parameter that shifts. So if you look at the article I gave you, what is it arguing is causing the increase, even though labor is shrinking? Capital may not be, I don't know. The labor employed is shrinking. Output's still going up, and capital is, let's say, pretty stable. What's causing the increase? A, that's the catch-all variable that we use to express technology. If you get improvements in technology, we just say A goes up. Okay, and so it enters that. Technology does not enter, is not part of L or K. It's something else, okay? And so we've got technological improvement going on, and then we would increase A. If you had a decline in the labor supply, which is happening now in a lot of countries, Japan's the biggie. Japan has a decline in the labor supply that was estimated at one time to be up to 20% of its labor force. It's going to shrink. Population shrinking. The working age population shrinking. Capital stock isn't shrinking that much. And what happened in Japan when this became known that and forecasted that was going to happen, the stock market crashed. That's the return on capital. Wages were starting to go up. That's the return on labor. And so you saw a huge change in the payment to labor and capital. That was really independent of how hard people worked or whatever. It just had to do with the owners of capital took their losses. At that time, it was interesting. Capital is owned by the shareholders of corporations. Okay? And Japanese corporations are mostly owned by Japanese pension funds and so on like that. Japanese pension funds took a huge hit. Asset prices in Japan, the stock market went from around 40,000 when this whole thing was first recognized as starting to happen, and got down from 40,000 to 8,000. Okay, that's a huge drop. Real estate prices fell to 1/10 of what they were. Okay? All these prices were dropping. What were the Japanese doing? The pension funds and investors. Well, we're still producing goods. The population decline hadn't really set in yet fully. And they were exporting all these goods. And what were they importing? Well, they weren't importing Americans goods. That got a lot of people upset. Unfair trading practices and so on. They were importing our financial assets. And so there's a big trade deficit in the U.S. where we were exporting financial assets and importing current goods. Just the opposite for Japan. Okay. And so that was the situation. And wages were rising in Japan. Asset prices, of course, collapsed. And meanwhile, the U.S. stock market's just humming along, and people were saying at the time, well, the same thing's going to happen in the U.S. We're just going to be a few years behind Japan. Well, that didn't happen. Okay, we weren't suffering the population decline. Right on the edge right now. And that's why some people think of dealing with immigrants and trying to block them out as a bad thing, because our internal growth in our population is not as significant as it was, and the population could start declining, not just like in Japan, but something similar to that. And that's not good. And the last time we saw, very early time was back in around 1300, 1350 with the Black Death. Plague came through. Population shrunk to about, let's say, half of what it had been, due to that wages to workers went up because there were fewer workers. Landowners became impoverished because that was the capital of the day, the nobility, and it was the demise in Europe. It was the demise of the nobility. They were impoverished because they didn't have the cheap labor force anymore. They started bidding over with each other for the peasants, and to return to peasants. England even passed a law prohibiting peasants to dress like noblemen because they had the money to do it. Okay, because they were rewarded. So anyway, that's kind of funny. You can't dress like me because I don't want you imitating my brethren in that way. So anyway, so we have a function here. So let's graph this function now. And I'm going to graph it first with respect to labor and Y. Y is real GDP. You can think of it as Q, if you will. Output. Okay. And we see that as you apply more labor to the production activity, output increases, but it increases at a decreasing rate. Because you're keeping capital the same, you're keeping technology the same, and you're doing this. So what you're getting here now is a function. Graphs something like this. This is f of L K fixed, or also A fixed and L the alpha times K the beta fixed. The K is fixed. Okay? So that's just that would be the graph of that. I made it because as you add more and more labor, output goes up, but at a decreasing rate. That's why the curve is flattening as you move outward along the horizontal axis. As I add more and more labor, total output's going up, by smaller and smaller increments as I add additional workers. That's based on something we have in economics called the law of diminishing returns. If you keep all of the factors fixed, you just expand the use of one factor, holding everything else fixed, the additions to output in this case are diminishing. Incrementally, not negative, but they're smaller and smaller increases as you keep expanding the amount of labor. This graphs into the addition to output here. When we do this, by adding a little bit of labor here, this addition to output there is the marginal product of labor. You can see as you move out along the horizontal axis of labor, you're moving up along the curve, okay? You're paralleling that, and you're seeing that the additional increments for each additional unit of labor are getting smaller and smaller. That's the marginal product. The marginal product of labor is up here. The addition to output, that's in units of Y, okay? Dollars per unit of additional labor, output from labor. Marginal product is output contributed by labor, right? And so you'll get a curve now that looks something like this. Marginal product of labor, which is a function of labor, capital fixed. Okay? Okay. What is that? What would I do to get that? So, has anyone ever heard of a derivative? The first partial derivative of that function, derivative of L, partial derivative means you hold everything else fixed except L. And you vary L, that's what this is doing here. You're holding everything fixed except for L. It's generating this curve. And then the child of this curve, let's call it, is the marginal curve. The function for the output is this function up here. The function for the marginal product of labor is the derivative of that function. That's another function. Okay? It's like the relative, the child of the other function, if you will. Okay? And so you've got here this function right here. If this function, something happens, for example, if A goes up due to something like maybe an improvement in technology, technological revolution. Do we have any technological revolutions? Well, the first technological revolution we know was the beginning of the Industrial Revolution, called the steam engine. And it started driving production machinery in factories and so on like that. It also drove railway locomotives and so on. Everything worked on steam. Then along comes electricity, and then along comes that. And then comes the computer. That's a new technological revolution, okay? And with that, we got growth. A lot of jobs eliminated by computers. I remember when I was on the faculty at UCLA, when we started getting personal computers in our offices, a lot of the secretaries started quitting. They were used to typewriters, and they said, I don't want a computer. I mean, they just got the jitters or something. And they were quitting right and left. Well, it turns out that all you ended up with in the end, the faculty, was we all had a personal computer in our office, ultimately. And we didn't have secretaries anymore. The only secretaries were those who answered the phone and dealt with mail issues and so on like that. But we didn't have typists anymore. We all did our own typing. And that was the transformation that took place there. So it's, I remember handwriting my papers, and then the secretary typed them up, and then I went in and edited them and reviewed them. You did not early on have the ability to cut and paste and you had to retype the whole damn thing, okay? So you would you'd get the draft from the secretary, then you would go in and make changes, additions, and changing the language and some various ways. Now, it all comes to one paper. You can't do it 4 steps. Now, what do? How do you do that? Well, you've got cut and paste, and you can just edit the document itself right there in the computer. You know, change the sentences and everything, and then save it. And that's what we do now. The technology has gone through that whole process where you had to have it typed by somebody who's a typist. But the interesting thing was that I saw a lot of people say, new technology, I can't handle it. And they just quit. And so it was kind of funny that some people had that reaction to it. But I can imagine it's happened through other past innovations where people were used to doing things a certain way and so on, and they just quit their jobs and when the new technology comes along. Okay, so I have this curve, and this curve is derived from this little increment right here is this little incremental change right here. Okay, and so all I'm doing is generating information for the marginal curve from the total curve. Okay, and that is done simply with calculus. I've just transformed the original production function into a marginal function. Okay, and that's all calculus does in this case, is it just transforms the one function into another, the derivative function. And so that has useful information. So anyway, we have this curve right here. What causes this curve to shift? Causes it to shift this way, or this way, up or down. Yeah.
Would it be the product?
What?
Would it be the marginal product that shifts it?
Well, that is marginal product. I just did there. What causes the marginal product schedule to shift?
Oh,
This curve has to shift over here.
labor.
And what causes that to shift?
Would that be labor?
No, labor is the movement along the horizontal axis. So along that curve, you're varying labor. That's what you get. So what are the other possibilities?
Y output.
No. Y is dependent upon L and K. What's the other obvious one?
K, capital.
K. If I increase K, what happens? For any given amount of labor, if I increase K, output goes up, doesn't it? And that causes the whole curve to shift upward. What about A? What if we have technological improvement that reduces the amount of labor and capital it takes to produce something? Then a given amount of labor and capital generate a higher output now with an improvement, an increase in A, which would be an improvement in technology. Okay? That's what we've been going through here lately, is we're improving our technology. Okay? We seem to be relentlessly moving forward, not all the time, but you usually don't go back to an old technology that is an inferior technology. Okay? Okay. We learn how to do things better and better. Okay. And you don't say, oh, I'm going to go back to the old way. Okay. That says I want to be poorer, basically. Okay. So we have this now. So this is a curve we can generate here based on various things. Can we do the same thing for capital? Well, this is going to dry up on me. Let's do K along this axis, put Y along this axis, and then now we hold L fixed and we vary K. That's the first diagram in that chapter on output here. The chapter that has to do with well, it's chapter 4, there's a 4 here. But it has to do with the model of production. That's written out on the second page of this handout. Okay. And so that's a total product of capital curve. What's it generated from? That function right there. Okay? And this time I'm holding L fixed and increasing K and graphing it. Okay? Is there another, what shall I say, relative of that curve that I could draw up here now? That's also a function of K. This is a function of L and K holding L fixed now. So this production function you can use it to generate these two curves. One is a output as a function of L. Output is a function of K, and then I can have the siblings, let's call it, the children, that are the derivative functions, the marginal products. Marginal means what? Think of it as small incremental changes. That's the margin, not the total, the marginal. So in economics, you get the marginal and you get the total. Almost all upon, now I did this when like I said, when I did the Robinson Crusoe thing. When I got the marginal cost schedule, I essentially differentiated a production function to generate that curve. I had it sloping downward to the right. I'm sorry, upward, the cost was going upward because of the shape of the curve. And then I brought in the marginal valuation schedule. Well, that's a derivative too. I just did not outline the preferences in a way at all rigorous. And you saw that when you maximize the total well-being in a person, well-off as they could be, you maximize the difference between the total value and the total cost. And the total value was the sum of the marginal valuations. The total cost was the sum of the marginal costs. And as long as the marginal cost was less, for another unit was less than the marginal valuation, it was worth it for you to have another unit. It's worth more to you than what you have to give up to get it. The opportunity cost being the other good that you sacrifice in production. Okay? And that's what economics is all about, is saying, why do people do what they do? They behave rationally. How do you formulate that? You use them, when you want to solve a problem, you say, well, they just do what they do? No. They go as if, and you know people don't do this, but they do as if they're looking at the marginal valuation and the marginal cost. And they keep expanding that particular activity, or whether it's consumption or production or whatever, until marginal cost equals marginal valuation. And then you maximize the joint gain. You're as well off as you can be. Okay? Any questions about this? In economics, you do this over and over again. Okay? It's that simple. In your business courses, for those of you who are business majors, you're going to do this over and over again. So I think we got on. It's not, yeah, you have a calculus of thought process about determining when do you maximize profit? Well, when you produce the first unit, there's a certain profit. You keep expanding as long as the marginal profit from an additional unit of output is greater, okay, is positive. What happens when marginal profit hits zero? Well, usually if you go beyond that point, produce more, the marginal profit becomes negative. Okay. You want to start incurring negative profit, negative increments to your profit. You're now starting to reduce the total profit, not maximize it. Okay. So you set up these problems like this, and once you get the hang of it, it's really simple. Okay. This is what enamored me in a way about economics when I was an undergraduate. I took this economics course and I thought, oh my God, you can actually handle this. You can do this with this structure like this. And then you can start using it to start making conclusions. Okay. Now, what we want to look at here is what's the consequence, okay, of this part. You're going to employ labor and capital. Employ additional units of labor as long as it's profitable. The return, the marginal gain is greater than the marginal. You do the same with capital. Okay. And you can get that. I mean, what I've left out here is a marginal cost function. That's another complication that comes in later and so on. But you want marginal cost. You keep expanding, as I said in the Robinson Crusoe, you keep expanding your consumption, your output, whatever, until marginal cost equals marginal revenue. The addition to cost, as long as marginal revenue, the addition to revenue from an additional unit is greater than the addition to cost, then you produce another unit. When you hit the boundary where the marginal cost equals marginal revenue, you don't want to go any further. Because if you expand another unit, now marginal cost is greater than marginal revenue. Okay. So sometimes I use the example like, if I have $1 and I ask you, would you give me 90 cents for $1? Would you do that? You bet. Actually, was giving me 10 cents gain here. Well, what if I gave you, instead of $1, I asked you to pay 91 cents to get that? Is it worth it for you to pay 91 cents to get $1? 100 cents? And you keep doing it, and I go up to where it's 99 cents you have to give up to get $1. Well, it's not as good as early, but yeah, I'll do that. That's another penny. I'm still ahead. What if I say, would you give me $1.02? $1.02 to get $1, and you say, what? What do you think I am, stupid? Okay. That's all we're saying here. That's what rational behavior implies. Is that if you get to the point where you say, no, that's no longer in my interest. The first offers you made were great. Now you gave me a bad incremental deal here now. I don't want any more. I'm not going to pay more than $1 to get $1. Okay. You want to give me less? If I have to pay less, okay, I'll take the $. That's just simple. You're just looking at money there. Okay. So you can do the same thing by thinking, how much of a good do you want to buy? Well, if your marginal valuation, what it's worth to you for another unit, is greater than what you have to pay, and you say, well, I'm better off. I'm giving whatever I'm giving up alternatively when I pay this price. It's worth less to me than one more unit of this. Okay? So I keep buying additional units as long as my marginal valuation is greater than the opportunity cost, the value of the foregone alternative. And I keep doing that, accepting those offers until it's no longer in my self-interest. And that's what economists are assuming. People behave what? In their self-interest. Now you have to be careful about this because there are generous people who care about other people as well. Okay? So I used to jokingly say, when I go to Beverly Hills and I see a vagrant there, walking along the street, I stop and give them $20. I want them to stay in Beverly Hills. I don't want them coming to Malibu. So that's one little piece. Another thing is, when I see someone and they kind of look like they're hustling stuff, I give them money. I want them to go away. I want to have a safer life. And I don't want to give it to the point in which I get robbed in the sense that they do that. But there is something about living in a world in which you're relatively generous to people. Because you think about it, this person could do harm to me. I don't want to have to fight every square inch I walk through, or every inch I walk through. And there's some places where you pretty much, that's the way you get through safely, right? Okay. I had a friend who got mugged. Sam Palsman, who's a famous economist, got mugged in Chicago going across what's called it's the wide expanse between one part of the city. It's a huge area. There's roads going both ways, a big green area there. It was still up there at the University of Chicago. I can't think of the name of that, but anyway. And he got mugged. Shouldn't have been walking in the dark through that area. He's vulnerable. There were a lot of street lights. Okay. So a few nights later, walking a little more carefully, and he sees somebody who looks like like the guy who robbed him. And he goes over and grabs him and says, give me the watch. Turned out it wasn't his watch. He robbed somebody else. So anyway, you have to be careful when you do that. But he thought he found the guy who stole his watch. So anyway, you have to be careful out there. Any questions about this? So this is what we're talking about here now in terms of getting an idea. How much labor and capital do you employ? You employ labor and capital as long as the return from doing so is related to the cost. Okay? You have to know what the cost is. And of course, individual firms face in a competitive world face prices of inputs. The cost is what they have to pay for the input. What's the return? The value of the additional output they produce from those inputs into the production activity. And of course, the production activity is much more complex than just two input. Here we have labor, and then they usually say, well, everything that's not labor, I'll just call it capital. Those materials, whatever it is. That keeps it simple. That's what your textbook essentially does. It keeps it simple. Okay? If you get into a production function, maybe the variables go on and on and on. It's a very complex world we live in. I was visiting my brother up in a little town called Crockett, which is next to Richmond, which is where there's a big Standard Oil refinery. It's a research refinery as well. There's a guy who came over to help us pick grapes. He was a chemist at that, and a petroleum engineer. Engineer in the sense he was involved in refining there. And I asked him, how many byproducts come out of a barrel of crude oil? And, so probably at least 100. You think of plastic, rubber, various chemicals, on and on and on. Oil is a really vital material for so many different things. I think 100 byproducts can be made out of individual out of oil. I didn't know that. Okay, but I know there are different, there's oil, there's gasoline, obviously, there's jet fuel, there's all kinds of different things you can get out of it, and there's fertilizer. Okay. And plastics, on and on and on. Okay. I had no idea until I asked the question, and then I started thinking about it, well, that's a silly question to have children. You know there's gotta be a lot of stuff coming out of that oil, okay? So, that's the world we live in, a very complex world. Okay, any questions? Okay, well, I'll see you on Friday.